Okay, good morning everyone. I hope you can hear me. Okay, for today, we are going to start on the lesson on bases. Okay, it's a very important chapter. We have finished the chapter on acids, so now we are going to look at bases. Okay, first question: what is a base? This is the definition of base. Previously, I got mentioned bases are substances that ends with the word oxides or hydroxides. Okay, so over here I have some examples of oxides and hydroxides. Example are copper 2 oxide is a black substance. Okay, magnesium oxide and so on and so forth. Or you can also have hydroxides like magnesium hydroxide, aluminum hydroxide. Okay, all these are bases. Okay, next. There are some bases that are soluble, some bases that are insoluble in water. So the question is, what is an alkali? Alkalis are also bases, but they are the ones that are soluble in water. So if you want to do a simple category, I have bases. Okay, bases are basically oxides or hydroxides. The next question is if they are soluble or whether they are insoluble in water. So the ones that are soluble in water, we call them alkalis. Okay, so alkalis are also base, just that it's soluble in water. Okay, so what are the alkalis that I have? So an alkali is a soluble base which produces hydroxide ions in water. This is a super important definition. Okay, why? Because of this ion OH minus. Okay, so over here, if you look at it, I have various base alkalis over here. The last four is actually my SPCA. Okay, I believe I mentioned SPCA. So all my SPCA hydroxides, they are actually the alkalis because they are actually soluble. They are my soluble base, and that's why I call them the alkali. Okay, let's run through SPCA real quick. Okay, S stands for sodium, P stands for potassium, C stands for calcium. This calcium is sparingly soluble. I will still consider it as soluble. Okay, A stands for ammonium. Okay, I repeat. A stands for ammonium. Let me write it down. Ammonium hydroxide. So what is ammonium hydroxide? Ammonium hydroxide is actually equals ammonia. Okay, it's actually equals ammonia. So that's why it's here. Okay. How do I know it's actually equals ammonia? Because this ammonia put inside water, you dissolve, it forms aqueous ammonia, or layman term they call it aqueous ammonia, but actually it's ammonium hydroxide because it has an NH4 plus and an OH minus. This is a weak alkali. How do I know it's weak? Because there's a double arrow. So it's a weak alkali. I hope by extending your knowledge of weak acid, a weak alkali means an alkali that dissociate partially. Okay, it doesn't dissociate fully. So in other words, by aqueous ammonia, you have a double arrow. When you try to dissolve ammonia in water, not every single ammonia molecule will become your ammonium hydroxide ions. Okay, let's move on. So let's look at some properties of alkali. Okay, alkalis, something that you learn, I think, lower sec. So now let's run through the standard properties. The first one is the taste. It's a bitter taste. It's slippery, also soapy feel. Okay, so this one you will have heard of it before. Next one, alkalis have pH more than 7. They turn red litmus paper blue. universal indicator will be from green to become blue or violet. This one is something that you learn in lower sec as well. Alkalis can conduct electricity. The reason is because there's mobile charge carriers, or in other words, there's ions that are mobile. Okay, why? Because alkalis are soluble base. Okay, they can dissolve in water to produce OH minus ions. These ions are aqueous ions, they can move. So by definition, you already know they will produce hydroxide ions and are mobile. And that's why they can conduct electricity. Next, alkalis react acid to form salt and water. This is not a neutralization. This one is the same chapter under acid. Acid react alkali to give you salt and water. Okay, I'll write it here one more time. Acid plus alkali, or you can call alkali plus acid. They are the same thing. Or 1 plus 2 is the same as 2 plus 1. So acid plus alkali or alkali plus acid will give you salt plus water only. This is a neutralization reaction. Okay, the neutralization reaction, if you want to write out the ionic equation, it will be this form. Okay, you can go and try it out. Okay, next, alkalis can react ammonium compounds on heating to give a salt, water, ammonia gas. Okay, this is the very long equation. Okay, so how do we go about it? Let me just write for you. Alkali plus ammonium salt. When you put these two things together, you'll get salt, ammonia, and water. Okay, I put a star. It's very important, this equation. Okay, later you'll know why. So when you put these two things together, you get three things out of it. Okay, the first question, what is an ammonium salt? I trust you know what is an alkali. So what is an ammonium salt? Ammonium salt basically will contain ammonium. So there's a word ammonium over here, and as well as an ammonium ion. So ammonium salt will contain ammonium ion, NH4. Okay, a salt, at the moment, a salt will end with chloride, sulfate, or nitrate. So I write down some examples for you. The ammonium salt can be ammonium, chloride, ammonium sulfate, or ammonium nitrate. Okay, so these are the few possible ammonium salt, or you can call it ammonium compound. It's a compound that comprises of this ammonium ions. So when you put them together, you get salt, ammonia, and water. Okay, next, ammonia is a gas. Okay, let's not confuse. I'm talking about this one, ammonia. Ammonia is a gas. So to test for a gas, we can do this. Okay, it's an alkaline gas. It's under the chapter 1. It's an alkaline gas. So to test an alkaline gas, you must use red litmus paper because the red will turn blue. However, the most common mistake 99% of the students will make, you must include this word. Definitely, you must include this word called moist. Moist means layman term, wet. Okay, the word moist must be there. Why? Because although ammonia is an alkaline gas, but you need to dissolve it in water to become an alkali. So let me run back to the equation just now. See, this is the equation. This is my ammonia gas. If you look at the formula, it's NH3. NH3, it means to say there is no OH minus ions. So you don't find any OH minus ions inside one. There's no O, it's NH3. There's no oxygen. So when there's no OH minus ion, you will not produce any OH minus ion. And when there's no OH minus ion, you don't get any of the properties listed below here, because all these are the properties. So if you try to use a red litmus paper, it will not turn blue. You must dissolve it in water to produce this reaction. Then you have your OH minus ions. Then the OH minus ions is the one that trigger neutralization, because need OH, trigger the litmus paper from red turn blue. So in other words, your paper that you are using, red litmus paper, must be moist. There must be water on it. So when the gas touches the red litmus paper, it will dissolve in the water. Then when it dissolves, it will trigger the OH minus, formation of OH minus ion. And when there's a OH minus ion present, then it will trigger your color from red to blue. Can So after saying so much, to summarize, the word moist must be there. If it's a dry or normal red litmus paper, there will be no change in color. Even though it's an alkaline gas, no color will change. Okay, let's move on. So alkali will precipitate insoluble metal hydroxide. Okay, what is this? The word is insoluble. So as you can see, the state symbol is all solid. Solid. Okay, it means to say it cannot dissolve. It's insoluble. So if it cannot dissolve, it will remain as a solid instead of dissolving. So the state symbol is a solid. All these are hydroxides. Okay, copper 2 hydroxide, iron 3 hydroxide. All these are hydroxides and they are all insoluble. You will study all these under the chapter of salts, which is coming out very soon, the next chapter. So I will not elaborate here. Okay, what is precipitate? We also not elaborate here. We will talk more when the chapter of salts is here. Okay, next, strong and weak alkali. Similar to strong and weak acid, okay, a strong alkali will completely ionize. So it's a single arrow. In other words, if I give you 100 molecules of sodium hydroxide, sodium hydroxide don't exist as molecules. If I give you 100 sets of sodium hydroxide, all my sodium hydroxide will ionize, okay, to become ions. That is a strong alkali. But if it's a weak alkali, it will not completely ionize. It will only ionize partially. So that's why there's a double arrow. Okay. After that, some of the ions will go back to the original. So as you can see, my aqueous ammonia, together you put them together, it's called aqueous ammonia because you're trying to dissolve ammonia plus water here. So my aqueous ammonia is a weak alkali. Okay, and you definitely need the water to get my OH minus ions. Okay, so some of the uses of alkali, let me see. All these, only the fourth one is, the third one, the fourth one is more important. The rest, you just read for your info. Okay, the third one, the fourth one, you'll see them appearing again. Okay, let's move on. Questions. Okay, so over here, I have a graph. This is the last year exam question. So during a spillage of hydrochloric acid, they are using substance Q. This substance Q is supposed to neutralize the acid, so it becomes pH 7, which is correct. Eventually, it will become pH 7. So by pouring the substance Q, the substance Q will remove all the acid by reacting with it. Until there's no more acid, then your pH goes back to 7. Based on the graph, what could possibly be Q? Okay, first of all, I need to react acid. You must understand this thing cannot react acid. You want to react acid, there's only a few possibilities. Number one, acid plus metal. Always make someone happy. Acid plus carbonate. Acid plus carbonate is all Chinese speak Chinese dialect well. Then acid plus base or acid plus alkali. So you cannot choose a carbon. Carbon doesn't belong to a metal, or carbon doesn't, it's not carbonate, carbon is also not a base. So the one out. Okay, next you cannot choose this because it's an acidic gas. Okay, how do I know? The previous chapter got teach. Okay, chapter 1, on the title called gases. It's an acidic gas. How can acid react acid? No lah. Acid react acid, you become still acidic lah. It will not become pH 7, okay? Neutral. So if I want to remove the acid and become neutral, I have to use something that can react with my acid. I left with two options. I have calcium carbonate and sodium hydroxide. Right now, I believe a lot of people would think the answer is C, but the answer is not C, even though the notes here is focusing on alkali, but it is not C. C is wrong. It should be A. Why? Because of this word, excess. It's a one word that changed the fate of the question. The question is excess. So if you imagine I'm pouring much more Q. I pour a lot of Q. So if I try to pour a lot of sodium hydroxide, what will happen is, yes, all the sodium hydroxide is alkali, it will react my acid. But because I pour so much sodium hydroxide, there's too much of sodium hydroxide that I pour. Too much meaning all the acid is gone, all reacted already, but I still keep pouring. Then eventually our extra of sodium hydroxide left, and my sodium hydroxide is alkali. The pH is about 14. It's a strong alkali. pH is about 14. Then the graph will look like this. But in this case, it's not the case. Okay, so I cannot. The answer should not be sodium hydroxide. The sodium hydroxide, the end product is you have too much alkali. The graph should end at 14. So I left with answer A lah. Answer A is calcium carbonate. Calcium carbonate is not alkali. It is neutral. Okay, calcium carbonate is neutral. So if I keep adding a lot of calcium carbonate, no problem. I will end up with 7. And if there's still any more acid, I just throw in lots more of calcium carbonate to remove all the acid. Eventually, I will have excess calcium carbonate, but that's fine with me because calcium carbonate, the pH is 7. Okay, next question. The following reactions are, what is E, F, and G? Okay, so let's run through it. You don't need to be too bothered by the chemical names. I think the question is purposely created to confuse people. I have acid and carbonate. Acid and carbonate is all Chinese speak, Chinese dialect well. So this must be carbon dioxide. You need to think. Then the next one is, maybe you see this word, you like, huh? Okay, so what is this? This is actually an ammonium compound or ammonium salt. Okay, so I have an alkali. You must quickly spot this is an alkali. So the reaction over here is just now that very long equation. Alkali plus ammonium salt will give me salt, ammonia, and water. Okay. Any questions? So there is a way to memorize this which is invented by a student of mine, but it's not very positive. Okay, but nevertheless, I shall share with you because it's something that is you will retain in your memory most likely forever. Okay, so how to memorize this equation? But before that, the answer is ammonia. Okay, because based on this equation, the gas is ammonia. So I think E is carbon dioxide and ammonia. Okay, so how to memorize this equation? Okay, I have always make someone happy. I have all Chinese speak Chinese dialect well. I will have all, stands for A. This is too long, so I call them all S's. ASS, all S's, ASS, yeah. all acids are white. Oh, yeah. So I say again, this is invented by my student. Can, yeah. But it serves as a good memory. I mean, you can remember it for life. Okay, all acids are white. So alkali plus ammonium salt give you ammonia, salt, ammonia, and water. Okay, my last question. Back to the question. What is compound G? So compound G, you look at it, it's an acid react with alkali, a weak alkali. So acid react alkali will give you salt plus water. So they are actually asking for salt. Salt is your G. Your G here. Okay. So this one you haven't learned the chapter on salt, so I won't blame you if you can't understand the answer. It's an ammonium salt because I have ammonia as the weak alkali, so as ammonium salt, and the salt will be ethanoids because it's ethanoic acid. Okay, I repeat, it's ethanoid because it's ethanoic acid. So if sodium chloride, it will be hydrochloric acid. The acid will be hydrochloric acid. So it's ethanoic, it will be ethanoic acid. If it's sulfate, it will be sulfuric acid. If it's nitrate, it will be nitric acid. Okay? So that's the D. Okay? Can? Okay, no question. I will move on to the number 43. Let me close this one. Okay, so for number 43, you can get your notes ready lah. It's indicators. Okay, indicators is a chapter whereby you just memorize. Nothing much to talk about. Okay, indicator is a substance. All these are my definition. Usually you observe my notes. The first bullet point is always a definition. So what is an indicator? An indicator is a substance that must be able to give you various different colors when you use the indicator in an acidic as well as an alkaline solution. So there are some common indicators, example litmus, metal orange, universal indicator, and phenolphthalein. Phenolphthalein may not sound like a common word to you, okay, but in the world of chemistry, phenolphthalein is a well-known indicator lah. Okay, universal indicator, some people call it short form UI. You may hear me say UI. UI is universal indicator, okay? Okay, after I talk about what's indicator, let's talk about what's pH. So what is pH? I think maybe you heard of pH 7, pH 5, pH. So what exactly is pH? pH is just a unit, like maybe degrees Celsius, 10 degrees Celsius. It's just a unit to measure exactly how acidity or how alkaline or how basic some substance is. Okay, but you must understand it only works when it's dissolved in water. If you don't dissolve in water, you cannot talk about pH. In other words, it must be a solution. So a solution, we can measure pH. Okay, so if it's a neutral solution like water, a pure water, distilled water, the pH is 7. Then next, any number that's less than 7 is acidic. So 1 to 6.9 is acidic. Okay, then anything more than 7, 7.1 to 14 is alkaline. So now the question is, you must know strong acid, weak acid, strong alkaline, weak alkaline. So the smaller the number, the stronger the acid. Then you must understand strong acid means the one that can fully ionize. Then that means this one is weak. Okay. Then the alkaline wise, the weak one is the one that is closer to 7. But the number the bigger is the one that is stronger. So this is a strong alkaline. Can you need to know the numbers well. Okay, let's move on. Now concentration of H plus and OH minus. So another way to look at pH, other than it's just a number, is actually the concentration of ions. There are two ions that we are interested in. The first one is the H plus, the second one is the OH minus. So we always compare these two ions. Okay, why? Because these are the definition for acid. Acid is a substance that produces H plus ions when you dissolve in water. Alkali is a substance where it produces OH minus when you dissolve in water. So these are the two important ions that give rise to what is an acid and what is an acid and what is an alkali. So when you want to see whether something is acid, you look at H plus. When you want to see something whether something is an alkali, you look at OH minus because that's the definition. So when we look at these two, we can actually also look at something that's neutral. So when there's something that's neutral, what does that mean? It means that these two ions, they are equal in concentration, equal in amount. When they are equal in amount, the pH is 7. That's also the reason why I have this ionic equation or neutralization is to form neutral solution. So when it's neutralization, what's actually happening is the H plus in my acid, the quantity, the concentration is just nice enough to neutralize all the OH minus ions in my alkali. And thereafter, since I do not have an excess of either H plus or OH minus, they are both equal in concentration. It forms a neutral solution, and that's why we call it neutralization. So the H plus concentration and OH minus concentration, they are the key players to determine whether something is acidic. Can so when I say lemon juice is acidic, it does not mean that there's no OH minus. There are OH minus ions inside lemon juice, but it is that there are more H plus ions, so it appears to be acidic. Okay, can likewise it's also true that if I say aqueous ammonia, it does not mean that aqueous ammonia don't have H plus ions. It has, but it's just that there are much more OH minus ions, so it appears the overall pH now turns alkaline more than 7. Can okay. So now let's move on to, if you don't understand, you rewind the video again. Okay, next one, let's move on to indicators. Okay, I have so many indicators, so you need to memorize all. Don't need you just need to memorize the first two. Okay, the remaining 3 is bonus. So what do we need to know? Okay, first you must need to know the name of the indicator. Methyl orange is a very common indicator. Okay, you will learn it very soon in the next chapter. It will come to play. So methyl orange is the indicator. It can test whether something is acidic or alkaline. Okay, if it's acidic, it will be red. If it's alkaline, it will be yellow. Okay, for litmus paper, acid will appear red and alkaline will appear blue. Okay, then what is this thing called pH at which indicator change color? It means to say this is the number that any number less than 3.7, 3.6, 3.5, 3.2, 2.3, any number that is below 3.7, you will have red color. Okay, so the tricky part is I know that 5 and 6 they are acidic, but it will give you yellow color. Okay, so I mean this is a unique indicator. The pH value that changes color is at 3.7. So you can still have things like pH 5, which based on the information, it is an acid, but it will give you yellow color. So the yellow color here, when you use methyl orange, does not necessarily mean it must be more than 7 pH. Okay, it can be pH 5 also, because it changes color at 3.7. Okay. Okay. Then the one that changes at pH 7 is of course your litmus paper or that one clear cut. Okay. If it's change color means, if it turns blue means it must be alkaline. If it turns red, it must be acid because the number that triggers is 7. More than 7, less than 7. Okay, let's move on to the next one. So if I want to measure pH of a solution, how do I measure what number it is and how acidic, whether it is strong or weak acid? Okay, I need to have something that can help me to measure. So over here in this case, I can use universal indicator. Because litmus paper can only tell you whether it's less than 7, more than 7. But it cannot tell you is it super less than 7, like 1, or slightly less than 7, like 6. So it cannot, the litmus cannot tell you this. But universal indicator, in a way, based on the difference in colors, they can roughly tell you a range. So if you use universal indicator or UI, if you see a color being red, it means to say the pH is about 1. It's a strong acid. If you use the if you use the UI and it says yellow, that means it's a weak acid. It's a pH is about 5 to 6. Okay, likewise for the other side of the story. If you test, you get blue. If you test, you get purple. Both of them are alkaline, with purple being the strong alkaline. Okay? Okay, let's say you don't use UI. What can you do? You can use something that's digital, that relies on a number. It will show you a number that is even more accurate to the 1 decimal point. So this thing is called pH meter. So you can use a pH meter to measure the pH of a solution. Okay, how to do it? As you can see in the picture, there's a probe. Okay, you can dip it in and it will measure a number. It's more accurate lah, because it's a value based. It will give you a number. The other one is a pH sensor. pH sensor is something like a pH meter, but it's connected to a computer. The reason here why it needs to be connected to a computer, because the computer need to pump up a set of pH values, not just one number. Many pH values. This one only give you one number. pH meter only give you one number. Let's say, I don't know, maybe this is 11.3 lah. But a pH sensor will monitor and collect all the pH values over a range of time, because they are trying to monitor the reaction, or as the reaction proceed. As the reaction proceed means starting, then maybe after 10 seconds, after 1 minute, after 1 hour, you see what is the change in the pH. Does it keep going up? After go up already, then come down. So they will have a set of data with many pH values to see what is the trend. So as you can see, it is so much value. You need to connect into a computer. Okay. Okay. Next one. This is some summary of common items around us and their pH values. So I have lemon juice. I have hydrochloric acid. I have vinegar. All these are acid. I have milk. Milk is slightly acidic. I have water and blood and whatnot, toothpaste and so on. Okay. Okay. Done. Come, let's look at the exam question. I only have one exam question. Let's look at this exam question. Red cabbage. Okay, red cabbage. So I all these different numbers corresponding to various pH value. Which pair of substance can be differentiated using red cabbage extract? Now they are trying to test you lah. How to test you? Test you whether you know what is a weak and what is a strong. So I have aqueous ammonia is a weak alkali. Okay, I have potassium hydroxide is a strong alkali. So the pH values that I'm trying to separate is about 13 to 14, and we probably 8 to 9 lah. So if I use this one 8 to 9, yes, I'll see blue. 13 to 14, I'll see yellow. Okay, so A looks probable. Okay, if I try to use red cabbage, dip it inside, I'll see blue color. I dip into potassium hydroxide, I see yellow color. So I can differentiate this way easily between which one is potassium hydroxide, which one is something like. Okay, let's look at the other others. Okay, sodium hydroxide and lithium hydroxide. Both of them are strong alkali. How I know? Because it's SpCa plus group 1. Okay, this is a good one. This is also a good one. They are both strong alkalis. Both or it's about 13 to 14. So if you try to use, you'll get yellow both for both. So there's no way I can find out which one is which one. Okay, hydrochloric acid and carbonic acid. Okay, hydrochloric acid is very strong acid. It's about pH 1 if not 2. Carbonic acid is a weak acid. Its pH is about 6. So how do I differentiate these two? Unless, okay, so if 1, 2, and 6, 1, 2, and 6, they will all give you red color. So if you use this cabbage, red cabbage, uh, both are red. Both will give you red color. So there's no way to tell which one is which one. So cannot. Water is pH 7. Sodium chloride is also 7. Sodium chloride is a salt. It's a neutral one. So both also pH 7. You dip, both will give you purple. So you cannot differentiate. So the answer is A. Can? Any question? Okay, very good. If you don't have, we are going to move on to our very last one. And finally, we can complete this chapter online. Wow, it's an achievement. Okay, so this is the type of oxides. Okay, this one I must tell you, this entire thing, this entire number 44 is 5 star. Okay, Mr. Lee never joke with you. Okay, it's so important that yes, it's 5 star. You look at the number of questions coming out. There are a lot of things to ask. There are also a lot of things to memorize here. Okay, so what is this last part of this essay and base about? We are looking at oxides. I repeat, we are looking at oxides, not hydroxides, oxides. So as you know, oxide is a base. Okay, but we are going to focus on oxides, and there are 4. There are 4 types of oxides. What do I mean by 4 types of oxides? Okay, they are acidic, number 1, basic, number 2, amphoteric, number 3, neutral, number 4. Okay, so there are 4 types of oxides. Each of them have their unique characteristics. I will run through you now. Okay, so the first one, acidic. Acidic oxides, the word you say is acidic. So if I take my acidic oxide, example carbon dioxide. Okay, carbon dioxide is acidic oxide. So all the word will end with oxide, or any oxide. That's why it's called oxide. Okay, so all these oxides are acidic. Why are they acidic? Because when you dissolve them in water, it becomes an acid. That's why it's called acidic oxide. Oh, simple enough. But how do I know whether something is acidic oxide or not acidic oxide? Very important. This is because as long as you check they are non-metal, like carbon, nitrogen, sulfur, phosphorus, they are non-metals, it will give you acidic oxide. Some are a bit tricky, like silicon. Silicon is a metalloid, half metal, half non-metal. Okay, or rather it exhibits both metallic and non-metallic properties. So you need to memorize silicon dioxide. But anyway, as long as a non-metal, it will be acidic oxide with some exception. Later I'll tell you the exceptions. Okay, so very easy. Non-metal, I see a non-metal oxide is acidic. All this now, you help me change the formula. I forgot. I don't know why this one never put subscript. The formula is H2CO3, HNO3. The numbers all small numbers, okay? H2SO4, and so on and so forth. Okay, can. Okay, so if you dissolve sulfur dioxide, I get sulfurous acid, not sulfurous acid. There's a difference between sulfurous acid and sulfuric acid. They are not the same. They are, one is H2SO3, the other one is H2SO4. Okay, let's move on. Okay, next. So acidic oxide, they are definitely acidic. Okay, so if they are acidic, they can react alkali. It's the same as acid plus alkali. Acid plus alkali to give you salt and water neutralization. So acidic oxide are acidic, so they will behave like acid and they will neutralize your alkali. So I can take a sulfur dioxide, I can take all this. they will react with my alkali to give you salt and water. What is the salt? Don't need to worry for now. You will need it very soon in chapter. Okay, next, basic oxide. So after I finish with acidic oxide, let's look at basic oxide. So what is a basic oxide? A basic oxide behaves like a base. Okay? Why? Because when you dissolve in water, they can form an alkali. Can. Okay, so I have all these alkali. Oh, all these are alkalis. They can dissolve in water. Okay? Or SPA, SPCA, sodium, potassium. All these are metals.